Hey guys, here we are having a very monumental day in math class. So I like to think about monumental days in math in my history. And I remember the very first day that I learned in elementary school that there were negative numbers. That was mind-blowing, and it is a monumental mathematics day. Same thing for the day you learned what Pythagorean theorem was and why it was and how you used it. That is a monumental day in math class. Today is one of those days. Today we're going to start talking about the unit circle. I'm so pumped for you guys to learn this. Okay, the purpose of the unit circle, which what I dare you to do right now is to actually Google image unit circle on your phone or something, and you're going to see a bajillion pictures of all the same thing. And if you have any friends or siblings that have taken trig, and if you mention the unit circle to them, it's the entire semester of trigonometry. This is a huge day for you guys. Just remember a couple things. The center here is at the origin. It's going to help us evaluate and compare trig ratios. We're going to be thinking, you're going to have dreams about this image of this circle with these random dots on it and stuff. Center's at the origin. The radius is always 1. That's why it's called the unit circle, 1 unit. And that means that anywhere you draw the radius on this circle, so like from here to here, this distance is 1. If I would draw it to this dot right here, the distance is still 1. If I use this dot right over here, the distance is 1. Anywhere around the circle, that radius is always 1. So just keep that in mind. And I also want to refresh your memory on some special right triangles. Do you remember in geometry class when you learned what special right triangles was? It probably was an entire chapter. And I want to recall why it's called 30, 60, 90. So it's a right triangle with a right angle. One of the angles is 30, the other angle is 60. That's why it's called a 30, 60, 90. Same thing with 45, 45, 90. Remember, it's an isosceles triangle, but it has two 45-degree angles and a 90. And just remember that since we're talking about the unit circle, the radius is 1, there is 1 unit. That means the hypotenuse here is 1, and the hypotenuse over here also is 1. So I want to help you remember what are the relationships, the stuff that you learned when you were in geometry class, between all of these sides. So remember the hypotenuse and the short side here. I'm calling this the short side because this is the small angle. This is the short side of the triangle. The relationship there is half. Maybe you remember that, maybe you don't. Allow me to refresh your memory. Or the short side, if you double it, you get the hypotenuse. That is always the relationship between the hypotenuse and the short side of the 30, 60, 90 triangles. And then similarly, if you go this way, if you multiply by root 3, that is how you get the long side. And I'm calling that the long side because this is my 60-degree angle. And so just keep that in mind. Do you think if I flipped this triangle upside down, I'm going to write multiply by root 3. If I flip this triangle upside down, do you think that you could still label the sides knowing that the hypotenuse is always 1? If I twisted this triangle or rotated it a little bit, do you think you could still plug in these 3 sides? Because that is what we're going to ask you to do in trig. Let's talk about the 45, 45, 90 triangle. Remember the hypotenuse is still 1, but if you divide by root 2, excuse me, that's how you get the length of the leg. And remember, this leg is the same as this leg because it's an isosceles triangle. Or if you have this side and you multiply by root 2 and simplify a little bit, you get 1. I just want to remind you about this rationalizing thing. You don't have to rationalize stuff, but if I could show you real quick, dividing by root 2, if you rationalize this, you get root 2 over 2, and that is why we got this. This is the same exact thing as this mathematically, and if you want to leave it like this, that's fine, but on all the Google images in the textbook, on worksheets, answer keys and stuff, I'm going to use rationalized answers for unit circle stuff. It is not incorrect to leave it like this, but I would suggest rationalizing just this unit circle stuff so that you can stay consistent. Okay, what else I want to do is I want to talk to you about these quadrants of the unit circle. So if you have a 30-degree angle on the unit circle, I'm going to tell you about what these dots mean. If I draw the 30-degree angle, remember my starting side, my initial side is right here, and I rotate up 30 degrees, that's what this first dot is for. Theta equals 30 degrees. And remember how we connect our triangles. I'm always going to drop it down to the x-axis, never to the y-axis. So I'm going to continue like so and put my right angle in. This is the exact triangle that I have right here. do you think that you can label these sides on that triangle within the unit circle? And so just keep in mind, remember that on the unit circle, the hypotenuse, aka the radius, is always 1, and that means that this side is 1/2 and this side is √3/2. And you just need to be able to, if I flip this triangle upside down or rotate it in any direction, you still need to be able to locate the 3 side lengths. Therefore, I'm just going to write it as an ordered pair like this. What is that ordered pair? I went right √3/2 and I went up 1/2. So this is √3/2 and this is 1/2. And that's the ordered pair. So I'm going to continue doing that. Let's draw the 45-degree angle here. This is my starting side. What do you think that second dot is for? It's for 45 degrees. We learned how to draw angles and stuff on the first day in the first video. I'm going to drop this down to the x-axis. This is my 45-45 triangle with a hypotenuse of 1. So remember the 45-45-90? It's this triangle, but it's flipped a little bit. Can you still label both of the side lengths? That is the entire semester of trig. This is √2/2 and this is √2/2, and that means I can come up with an ordered pair here. √2/2, √2/2. That means I went to the right √2/2 and I went up √2/2. It's just the triangle inside a circle, and you have to be able to label all the sides. The last dot is for 60 degrees. So remember, starting side is here, ending side is right there. Drop it down. This is my 60-degree theta. Remember, hypotenuse is always 1. Now my short side is down here is 1/2. It's just this triangle flipped and rotated. The long side is √3/2. Don't mind the bell. That means this is 1/2 and this is √3/2. So I've labeled all 3 of my points here, here, and here. I'm going to actually transfer these up to the top of the page so that I have them all in one spot, okay? So remember, I'm not going to draw all the triangles in, but this 30-degree angle, remember I went to the right √3/2 and I went up 1/2. I'm just going to label this ordered pair right here. The next one, that was my 45-degree triangle. I went right √2/2 and up √2/2. So this ordered pair is √2/2, √2/2. And the last one, 1/2, √3/2. There are 2 other ordered pairs here that I want to talk about, this one and this one, because they are still part of the quadrant 1 of the unit circle. They're on the axes. But do you have any idea what this ordered pair would be? Remember, the radius is 1. I believe that ordered pair in terms of x comma y would be I went right 1 and up 0. And then same thing over here. I go over 0 and up 1. Okay, so what I want to do now that I've labeled the first quadrant of my unit circle, and yes, we are going to continue this all the way around in a couple days, but what I want to do is I want to show you one other thing. Remember this chart of all the ratios that we've been talking about? So remember, for unit circle, the radius is always 1. So if I replace this with a 1 and this with a 1 and this with a 1 and this with a 1, that changes these ratios just a little bit. So that kind of means that for the unit circle questions, if I ask you anything about sine, I am really referring to just the y value. And if I ask you anything about cosine, I am asking you about the x value. So that is why something that's a little bit crazy, now that I'm asking you questions about sine and cosine, that really means just the x value for cosine and the y value for sine. So with that in mind, I want to show you what these examples look like. For the sine of 30 degrees, what that's asking me about, remember that sine is y over r, but r is 1. And so really the sine of 30 degrees is asking you, at 30 degrees, what's the y value? So these questions are actually really, really quick. I'm going to go all the way up to my unit circle that I labeled way up here. At 30 degrees, do you remember which dot was for 30? It was this one. Don't mind the bell. What is the y value of this ordered pair? 1/2. And so that is why I'm going to go down here and I'm going to write 1/2. I'm going to quit scrolling back and forth in just a second. I also want to show you a little bit of a longer way. If this is a little bit mind-blowing to you, you can do the old school, old-fashioned way to answer this question, sine of 30 degrees. And a lot of times what I'll do at the very beginning when I'm still learning these is I will actually sketch the triangle at 30 degrees. It's the 30, 60, 90. This is √3/2 and 1/2. And remember, that means that this side is 1/2, this side is √3/2, and this side is 1. Remember that sine of 30 degrees is just opposite over hypotenuse, or y/r. So you still get 1/2, but there is a much faster way to just refer to the unit circle instead. So just keep that in mind. A lot of times you will see me do little sketches like that as I'm starting to learn this and work my way through, because this is a little bit mind-blowing, but it should also bring you back to geometry class from 2 years ago. This is just technically review stuff. Let's go cosine of 45. So remember, cosine's x/r, but the r is 1, so the cosine is asking you what is the x value at 45 degrees. And so if you think the 45-degree reference angle looks like this, the x value is √2/2. Okay, again, if you want to think about it in terms of adjacent over hypotenuse, the adjacent side for our 45-degree triangle is √2/2, and remember that hypotenuse is 1, so the answer is still √2/2, but that's a little bit of a slower way of thinking about it. Tangent of 60. So tangent has x and y in it, so I'm going to have to do a little bit of fraction work. There's not really a shortcut for tangent, but yes, you will eventually memorize this stuff. At 60 degrees, I'm going to do a little sketch here. Remember what that ordered pair is? At 60 degrees, it looks like I went to the right 1/2 and I went up √3/2. Remember, it's just that 30, 60, 90 triangle that has been flipped and twisted a little bit. But remember that tangent is y/x. And so in that case, that means the y value is √3/2 and the x value is 1/2. And yes, we have to be cool dividing fractions. Remember, that means that you turn it to multiplication, you flip the bottom fraction, the 2's cancel, and we end up with √3. So yeah, a little bit of number crunching has to happen for the tangents, okay? I am also going to take that √3, the tangent of 60 is √3, and I want to label my unit circle with that. I'm going to go all the way back up. I'm going to find the 60-degree dot, which is this one, and I'm going to write the tangent out here in red. The tangent for 60 degrees was √3. I'm going to make a little note. This is going to be helpful for you. Remember how we're talking now about how the cosine questions are asking you about the x values? And remember, the sine questions are asking you about the y values. Well, tangent asks you about both. And there are very common questions that you'll eventually get really fast at answering. But for tangent of 60 degrees, the y value divided by the x value reduces to radical 3. So I want you to have a place to just quickly look up that answer, because I will ask you tangent of 60 a lot. Let's do a couple more, and then we'll be done and we'll practice this in class a lot, okay? Let's do sine of 0. Okay, what dot was 0 degrees? I believe that was the dot for right here. And remember, that ordered pair is 1, 0. Remember, 0-degree rotation means I'm not rotating at all. I'm stopping at the starting point. So 0 degrees refers to this dot right here on the positive x-axis. The x value is 1, the y value is 0. Remember, sine is asking you about y/r. And the r is 1, because it's always 1 in the unit circle. Therefore, the sine is just the y value, which is 0. Let's do another one. Cosine of 90. What dot is for 90 degrees? It's up here. 90-degree rotation starts at 0 and rotates up to 90. Remember, that ordered pair was 0, 1. I went left and right 0, and I went up 1. And remember that cosine is x/r, and the x value is 0, and the r is 1, and therefore 0 divided by 1 is 0. One more, tangent of 45. Okay, cool. 45 degrees. Do you remember that ordered pair? It was root 2 over 2 and root 2 over 2. So when I do, remember tangent is y divided by x. Yes, it's the same thing as opposite over adjacent, but since we're in advanced trigonometry, I'm using y's and x's now. Y over x means root 2 over 2 divided by root 2 over 2, which is 1. I'm going to add this tangent of 45. I'm going to add this number to the very top in red to my unit circle, so I don't lose that one. When you do y divided by x at 45 degrees, the tangent is 1. Okay, I do think that we are going to just stop there for now. That was a little bit of an introduction. I'm going to do like a warm-up in class to start and answer some questions and give you a couple things to think about, and then we're going to work on some of this group work in class in groups, and I'll pop into your breakout room. So if you have any major questions right away, message me. You know how to get a hold of me.